What are data structures? Singly linked list versus doubly linked list from a developer point of view. Complex analysis of a singly linked list versus doubly linked list. At is not available. There's no function for at a singly or doubly linked list. Size is, let's see, forward list calculates size on demand. Size is forward list calculates size on demand. O of 1, O of 1, O of n destroys all elements are destroyed and size set to 0. All elements are destroyed and size set to 0. Analysis of vector abstract data type complexity analysis. Pushback. Not available. Forward list has no tail pointer. O of 1 for doubly linked list has a tail pointer. Erase. Assumes you have an eraser point. Can erase only after eraser point. O of 1 assumes you have eraser point. Can erase only before eraser point. Splice. Not available. Forward list has no tail pointer. Splice. O of 1. Abstract data type. Insert. Forward list. Assumes you have an insertion point. Can insert only after the insertion point. Assumes you have can insert only before the insertion point. The default construction contains an empty container. Creates an empty container. C equals 1, C equals 2, O of n, O of n. Series of Vagrant. Push front is O of 1 and push front is O of 1. Resize is O of n, O of n. Find is O of n when your search begin to end, head the tail. O of n when your searches begin to end. Visit every element in print. O of n visiting every node from begin to end. Print. O of n visiting every node from begin to end. Print reverse. Not possible. Set us. O of n visiting every node from begin to Rn. Direction does not matter. Circular singly linked list with one dummy node. A singly linked list is a concrete data structure gay, not cool, consisting of a sequence of nodes. Each node stores a data element linked to the next node. No. No terminated singly linked list. A singly linked list is a concrete data structure consisting of a sequence of nodes. Each node stores data element linked to the next node. Mother. Inserting at the head, allocate and populate a new node. Have the new node point to the old head. Update head to point to new node. Deleting at the head, update head to point to the next node in the list. Delete the former first node. Thank you. Inserting at the tail, allocate and populate a new node. Have a new node point to whatever the tail node pointed to, namely name pointed. Point the old tail to the new node, update tail to point to new node. Tricky. Nodes. To create a linked list using dynamic storage, we need to create a class that has two data members. One to hold information, one to point to another object of the same class. The day I start eating is the day. Example code for a singly linked list. Singly linked list. Count d size d dot prepend row d dot prepend loud count d dot ds dot prepend and remove front prepend long d dot size d dot append d dot append d dot append d dot remove ds dot append long ds dot front. Singly linked list node null terminated. Template type name struct singly linked list node equals t value node t value underscore data std move value t data equals t node next null pointer. Singly linked list node circular code. Template type name struct singly linked list node tier equals default node t value dot underscore data std move value t underscore data equals t data node slash next equals this. Circular doubly linked list with one dummy node. Key idea. Keep a previous pointer in addition to a next pointer at every node. Keep a dummy node at the head of the circular list. Containers and iterators. Containers an abstract data structure that stores a collection of elements. Iterators abstracts the process of looping through the collection of elements. Let C be a container and B be an iterator over C. For P equals C dot begin, P doesn't equal C dot end plus P slash do something. Iterator categories. Iterators are objects that can iterate over elements of a sequence via a common interface adapted from ordinary pointers. Anything that behaves like an iterator is a iterator. Ordinary pointer is an iterator. However, iterators have even more abilities. STL containers and iterators. Each STL container called a C has an associated iterator. Begin, rbegin, returns an iterator to the first. End, rn, returns an iterator to an imaginary person just after the last element. An iterator behaves like a pointer to an element. P returns the element referenced by this iterator. Access current element plus P or plus P plus advance to the next element. Most STL containers provide the ability to move backwards. Minus P or P minus moves to the previous element. Iterating through containers. Let C be a container and P be an iterator over C. For P equals C dot begin does not up until C dot end plus plus P. P slash do something, which is a random function to do. STL vector example. Hashtag include vector. Int main, let's see, std vector int C equals -2, 5, -7, 0, 10, 100, and sum equals 0 for vector. Iterator P equals C dot begin, P doesn't equal C dot end plus plus P, sum plus equals, let's see, dereferencing P. STL singly linked list example. Hashtag include forward list int main std forward list int C equals -2, 5, -7, 0, 10,000, int sum equals 0 for forward list. Iterator P equals C dot begin, P doesn't equal P plus plus P, sum plus equals difference for like a singly linked list. Come on. More. Iterating through containers. Let C be a container and element be an item within C. For autos element C equals element dot do something. STL vector example. Hashtag include vector int main vector C equals -2, 5, -7, 0, 10, 100, and sum equals 0. For constant auto element C, sum plus equals elements. No. STL singly linked list example. Int main equals 0. std forward list C equals -2, 5, 7, 0. This is the singly linked example. Int sum equals 0. For constant auto element C, sum plus equals element. And I'll do that. There's STL iterator and say each STL container in type C supports iterator. C iterator reads us write iterator type C constant iterator read only iterator type C dot begin C dot end return start and end iterators respectively. C dot R begin C dot R end return start and end reverse iterators respectively, not for std forward list. stdl iterators in C++. Various notions of iterator. A standard iterator allows read access to elements. Constant iterator provides read-only access to elements. Forward iterator supports ++p. Bidirectional iterator supports ++p and -p. Random access iterator supports both p plus n and p minus n vectors and arrays. Auxiliary iterator functions. Dot advance, next, prev, distance. Gives all iterators some abilities usually provided only for random access iterators to step more than one element forward or backward to process the difference between iterators. Dot the advance function modifies the iterator position, increments or decreases position end times. Let the iterator step forward or backward more than one element. Still an O of n operation for list and O of 1 for vectors and arrays. The next and prev returns the position that would have if moved forward next and or backwards in position. It doesn't modify the iterators. Next works with forward, bidirectional, or random access iterator. No. Let's see. Prev works with bidirectional iterator or random access iterator, but not forward iterators. Distance returns the difference between two iterators. Still an O of n operation for a list and O of 1 for vectors and arrays. Considers std distance c dot begin c dot end equals c dot size. Distance c dot end c dot begin is a logic error. Yeah. What? No, cool. Example of iterator usage. Doubly linked list string list. Doubly linked list iterator it for iterator is a nested type. Iter list dot begin while iter list dot end. Count iter stdn plus iter. Example 2 equivalent but with a traditional for loop. Iter equals list dot begin or iter equals list dot end plus iter. Count iter end. Example of iterator uses. Int main list letters A, B, C, D, E, F, G for auto P equals R dot begin P equals R dot end plus pre count time pre if R does not equals N plus and then do that. Example from iterator use. Let's see. Count begin 0 plus 1 is less than n. Syntax error. Std count begin 2 and results in a b. Let's see. Std count begin 4 is a syntax error. Std count print is a logic error. Auto p equals count n. And std advance p slash 2. Count p slash n. Count call before begin. Syntax error. Key terms. An abstract data type, ADT, is an abstraction of a data structure that specifically specifies data stores, operation on the data, error conditions associated with operations, does not talk about implementation, container, adapter, wrapper class implementation, provide a public interface, but delegates the implementation to some other data device, data structure. Agent. Stack concepts. Last in, first out stack. Push. Insert elements into the stack. Pop. Remove the elements from the opposite order in which they were inserted. Last in, first out. Top. View the most recent element inserted. Real world examples. Deck of cards. Pile of books. Piles of money, and many more.